Good afternoon all, and let's try this beautiful problem. Find the minimal value of mod x square minus 4x plus 3 plus mod x minus 7 plus mod 2x minus 5. Now blindly if let's start this problem, as you can see we have three modulus here, but one is quadratic and other two is linear model. For linear we can do using triangular inequality as well, or there are geometrical interpretation also according to the weightage, or if we have even three complex number, let's say z1 z2 z3, and we have another point such that sum of distance is minimum, they can use uh, a very extended theorem of minimization principle, which will tell you that this point P should be such that the angle is 120 degree. It can be done by a conservative force method also, very interestingly using physics perspective. But here we have a different problem. So one of the obvious way of doing this, suppose if I call this as function f, then if I start differentiating to get minima and maxima. Now what is differentiation of mod of x? Mod x derivative. It's very fun way can be written as mod x by x. As you can see, mod by x is not defined at x equal to 0, which is clearly the case for modulus function. And whenever x is positive, derivative will be 1, which will be taken care of by this expression. For x negative, derivative will be minus 1. So this derivative I can write as mod x square minus 4x plus 3 over x square minus 4x plus 3 into its derivative 2x minus 4 by chain rule. Similarly for second term, mod x minus 7 by x minus 7, and we have mod 2x minus 5 by 2x minus 5 into 2. So as you can see, the possibilities for this expression will be either it's not defined or plus minus 1 whenever it is defined. Similarly for this expression it will be either plus minus 1 or not defined, and so on and so forth. So from here possibly we can get the critical point. As you can see, the denominator dies at x equal to 7, here denominator dies at 5 by 2, and we have that at x equals 1 and 3. So I know these are the danger points 1, 3, we have 5 by 2 and 7. Clearly I am not writing this in ascending order. As you can see, like 3 will come over here and 5 by 2 is somewhere, right? So these are the points where derivative is not defined. Now that is a good news, because in kind of linear mod kind of expressions we'll have curve like this. So that shows like at these corner points mod will not be defined. Even if we have quadratic, maybe we can have something like this kind of behavior. Okay, some quadratic like upward or downward parabola. So something like this, so where mod will not define at these corner points. So that's a good hint of doing this. So with this 4 special point, now we are ready to go with some other points where derivative might be 0 now, another critical point. So I know plus minus 1 combination of 2x minus 1, and we have plus minus 1, and this term is plus minus 2, so that should give 0. So let's play a little bit to see how many critical points we'll get. If I'll take 2x minus 1 and with 1 and 2, so that's going to give me 3, so it will give x equals minus 1, right? So that's another critical point. Similarly, if I'll take all the compositions, because as you can see we have 2, 2, 2, so 8 possible choice. If I'll take 2x minus 1 and plus 1 minus 2 equals 0, that's gonna give me x equals 1, which is already taken care of, so that's not required. And let's say if I take minus 2x minus 1 and plus 1 plus 2 equals 0, so that will give me 2x minus 1 equals 3, so x equals 2. So that is a new point that we are getting. So by doing this we can clearly get critical points, and with all these critical points we can plot this curve. Okay, but there is a nice way of attacking this question from a very basic perspective. As you can notice, even by this analysis, like all the three absolute functions are decreasing in the interval minus infinity to 1. So if you'll see the interval minus infinity to 1, all the functions are decreasing, all the three values are decreasing, mod values. Similarly, it is increasing in 3 to infinity, and that itself was a critical point, as you can check. Okay, so from 3 to infinity, all these are increasing. Why? Because from 3 to infinity this will just open as x square minus 4x plus 3, and even the slope y is 2x minus 4. So when x is more than 3, is clearly it has positive derivative. So this parabolic portion will increase from 3 to infinity. Again, from 3 to infinity, this will open as like 7 minus x, and this quantity will open as 2x minus 5. So this will open as either minus x plus 7 or x minus 7. In either case, the slope is positive, because if they add up, it will be x plus 2, or this is gonna be 3x minus 12. So anyways, derivative is positive, so it will be some bunch of line which is drastically increasing. So that's a good news. So just we need to investigate in 1 and 3. Now in the interval 1 and 3, the critical point that I need to check is 1, 2, 2.5, as you have seen here, and 3. Okay. Since f is a quadratic function with negative leading coefficient, hence the minimum value will be taken at the end points. As you can see, it's negative leading coefficient in this interval, this quadratic. So minimum value will be taken as end points. So just I need to calculate f of 1 value, f of 2, f of 2.5, and f of 3. Now f of 1 is quite simple. If we'll just in the entire expression we'll put, we'll get 4. F of 2 we are getting to be 2, and f of 2.5 is coming to 1.25, and f of 3 equals 2. And we know roughly the function was decreasing, and now we have so many values here. So the minimum value that I am getting is like it's 4 to 1.25. This is the minimum level where I am getting. Okay. And then again function is increasing from 3 to infinity. So I know the absolute minimum of the function is 1.25, and that is the answer for our question. So it was a basic idea like how we can use like differential calculus to get those critical points, and that will help you navigate the solutions. Okay, so both solutions gives me the second method. Hint was coming from the first method for those critical points, but in general there was no need to find all the critical points, because you see like this will involve evaluating like all 8 equations, which is not worth. So rather you can observe like the intervals where all functions is behaving in a similar way. Okay, let's move to the next question. It's again a very decent problems. As you can see, x is from 0 to 1, and this is a cubic expression equated with square root of 1 minus x square. We have to find the value of 2x square minus 1. Now clearly 4x cube minus 3x. 4x cube minus 3x gives a feeling of 4 times of something cube minus 3 times of something. It's like 3 has minus 4 has cube. So you must have encountered this structure in, yes, exactly, in trigonometry. So that 4 cos cube theta minus 3 cos theta kind of feeling is coming. So that motivates me to put x equals cos theta, since x is 0 to 1. So I am forced to use theta from 0 to pi by 2. Of course, I could take other interval also. 0 to pi by 2 is the most natural window of restricting this. Now, using this idea, if I'll plug x as cos in the expression given, so that boils down to cos 3 theta equals root over 1 minus cos square theta is mod sin theta. Now, since sin theta is 0 to pi by 2, sin is definitely positive, so it will open as just sin theta. And the solution is not difficult from here, because we can write cos 3 theta equals cos 90 minus theta, and that gives me cos 3 theta minus cos 90 minus theta equals 0. Now I can use the difference of cos A minus cos B, right? So that will be 2 sine 45 plus theta into sine B minus A, so 2 theta minus 45 is 0. So we have got two options. We are getting theta equals 5 by 8, right, which is 45 by 2, 22.5. The other options, sine of 45 plus theta equals 0 will give either this quantity 45 plus theta equals pi, or 2 pi, or 0, and so on and so forth. None of the answer will be accepted, because we are in this window 0 to pi by 2. So hence we got theta equals pi by 8. Now with theta equals pi by 8, we can evaluate 2 cos square pi by 8 minus 1, and that's nothing but just cos. 2 cos square theta minus 1 is cos 2 theta. So cos 2 pi by 8, and that goes to cos pi by 4, and hence answer is 1 by root 2. So it was very beautiful question, and you see like how trigonometry was inherently intimately connected with the questions. Okay, so the point was just to observe the integral details. How will you do it? Let's try one more question from PNC. You have to choose 5 integer from the set 1, 2, 3, 4, 5, 6, 7. For each choice, we define the score of it to be the second largest integer. Okay, so what we define? A score of choosing 5 integers to be the second largest integer. A score of it to be second largest integer. You have to find the sum of scores of all possibilities of the choices. For example, suppose out of this, if I choose 5 integers like 1, 2, 3, 4, 5, if this is my selection, the second largest is 2. Okay. Similarly, let's say if someone selects 1, 3, 6, 5, and 7. So of course, if I'll keep in the ascending order 1, 3, 5, 6, 7, second largest is 3. So like this, every time you select, you have to add all of them and give the answer, right? So this is also an easier one, because you can see for each I, if I select it from 1 to 7, how many sets are there such that I is the second largest, because I should be the second largest, and then we have 1, 2, 3, 4, 5. So if I is second largest, we have I minus 1 possibilities. For the smallest set, and I can select I minus 1, C3, and 7 minus I. So this many sets will be possible, so that I is the second largest. Is this clear? For example, suppose if 3 is second largest. So now I know like we have 1, 2, 3 numbers are larger than 3. Then the numbers that I can select here at their 3 place is 4, 5, 6, 7, right? So for 3 second largest, I can select 1, 2, 3, 4. Out of 4, I could have selected any 3. So let's say I could have selected 4, 5, 6, or I would have selected 4, 6, 7, or 5, 6, 7, and so on and so forth. So for every I we have, I'm using this. If you calculate, you'll get 112, which you can try it by yourself.